So, what I'm presenting today is, excuse me, a project I'm calling Hack the Hall. And so I'm going to give you a little bit of a backstory behind how I've kind of got into the whole physical computing IoT space, and hopefully that'll get some people interested in some ideas. So a couple years ago, I basically realized that the Docker raised a bunch of money, which is a tech company, and they released this open source extension that basically is a complete waste of money, and it was called Dockercraft. And basically what it was a way of controlling Minecraft containers, Docker containers from within Minecraft. No practical application, but cool in a nerdy sense. And so, being inquisitive, I looked in a little more into what was actually going into this, and there's a completely open platform that you can use to actually be able to control things externally from within Minecraft. And so I ended up building a thing where I could actually control my lights in my house from within Minecraft. Because everyone needs that.
That's what you were doing?
Yeah. And so, looking into this more, there's a whole huge community of DIY makers or hardware hackers that are really building cool things. And so what I'm looking to do is to try and think of ideas that we can use to apply these kinds of concepts to things at Indy Hall and make things better. So what is Hack the Hall? So effectively, the goal is to improve the Indy Hall experience through tech. Kind of a broad topic, but we're going to leave it that way. It can be both hardware and software projects, and I'm looking for ideas as well as people to help build and test things. So the first thing I'm going to cover is a couple pieces of hardware that I've known and used and that are pretty approachable. So the first thing here is going to be the ESP8266 and the ESP32. So I was going to bring devices to demo, but Amazon's guaranteed delivery by yesterday failed, so sorry. So the ESP8266 and the ESP32 are low-cost microchips that run at very low power. Specifically, they could technically be ran from a battery. And they're very popular with DIYers. So the ESP8266 has built-in Wi-Fi, and the ESP32 has built-in Bluetooth and Wi-Fi. So depending on what your requirements are, you can pick a device. They can be programmed in many languages, including JavaScript, the Arduino framework, Lua, and MicroPython. To give you just some context, this device here is more powerful than an Arduino, but costs maybe $3. So looking at the device itself to give you a little understanding of how it works, so this is the actual chip, this is the onboard memory, and then that's a Wi-Fi antenna. So it has basically everything that you need on board to do whatever you want. And these pins you can then connect to other things to start controlling. Next is the Raspberry Pi. So the Raspberry Pi is a credit card sized or smaller computer. They range in price from, at this point, I think $5 to $35. Literally today they just came out with a new model. They have very generous GPIO. So GPIO is general purpose input-output. So that's what you use, generally speaking, to control other things. So looking at these pins here, these are where all your GPIO headers are. And so you can use that to do a variety of things. They have a very active product and module ecosystem. So you can actually, there's a lot of hardware, especially open source hardware, you can use to make your Raspberry Pi do a lot of different things. So Google released something, for example, called the AI-Y kit, which was supposed to be like DIY, but for artificial intelligence. And basically what you were able to do with these kits is you can effectively build your own Google Home with a Raspberry Pi, which is cool. And then they have another one that is the AI-Y Vision, where you can actually, it's a standalone device using a Raspberry Pi and a camera, and you scan an object, and it'll actually use AI to tell you what the object is, which is pretty cool. And so the Raspberry Pi is easy to use because it's a more traditional computer. You install just a regular version of Linux. You can use a mouse and keyboard if you want, and it works very well. They have a really well-developed library for interacting with GPIO in Python. It's definitely easier for people looking to get started. So here's a couple project ideas that I have and have discussed with a couple people at the hall. first thing is going to be to build a SEPTA bus and train tracker. So the idea here is to create visual displays of upcoming departures for popular trains and buses, since that's how most people commute. So using something like a LED dot matrix, we can really do whatever we want. Print text, have scrolling text, whatever we want in that sense. We also have the ability to project this information on like a lobby, on the televisions in the lobby, using Chromecast. And also there's an idea within this to create a Slack command to actually get the next departure of whatever route you're looking to take. Next thing are phone booth occupied signs. And so the goal with this is to show a visual cue for when phone booths are occupied. I know a problem that I have is I'm going to look for a phone booth and I can't find one, or I don't know if someone's in it because they have the curtains on. And so instead of annoying people who are in the rooms by knocking or hovering, we could just have a simple light that sits on top of the room saying it's occupied, and then you know not to disturb people. And so to do this, we want to have a magnetic sensor that will check if the door is closed. So when the actual magnets hit when the door is closed, it'll send a signal. And then the other problem with that would then be, you can close the door but not have anyone in it, and that would be a false positive. So we can also have a motion sensor inside that just says if there's been motion in the last whatever X minutes, it'll send that signal to turn on a light.
Can I disrupt really quick feedback? What if you put a sensor, because there is an occupied thing with the lock.
Yeah.
So if you put a sensor at the end, that's a pressure sensor. If you could possibly get that, I mean, it might be part of the lock, but then you would know like it is locked and then wire lock to a light.
Yeah, that's definitely an option. And the last project is coffee analytics. So this has a lot of opportunities, not fully fleshed out, but given how important coffee is to Indy Hall, it's something that we should definitely explore. At the very least, being able to track each time a pod is brewed. So maybe some sort of sensor that will either be put into the switch that gets triggered when you brew a pot of coffee, or maybe something that we physically put on top of the switch that would be able to track it. We can use that and start getting visual data of how long it takes to drink a pot. When is the best time to get coffee. And maybe being able to put a visual cue when the coffee pot is low, so people know, hey, we gotta brew more coffee. And the most important is to tweet at Adam when we need more cream. And so that's it for my presentation. Any ideas or questions or comments?
But if you put a camera above the sink, so it can detect when it has anything in it, and then like five cams every day and have channels like every 10 minutes until it's clear. General.
Yeah.
Have channels. Someone does it and then it stops that channeling. Okay, all the people know.
Yeah.
Can you detect whether the pot's empty by using its weight, like a scale?
Yeah. Yeah, that's definitely an option. Yeah, I haven't thought about too much how to actually track that, but that's a good idea. Any other questions? Awesome. Oh, Kathy?
Are you actually implementing these?
Yeah, that's the goal. I want to actually have like a hardware hacking night where we get a bunch of people coming together and start building these.
Trying to think. I'm just thinking, I don't know if you're familiar with Food Cam at the Media Lab. It's basically kind of what it sounds like, but there's like a camera, there's a button. If you have free food to give away, you can press it and it sends an email to everybody in the building. So I don't know if it's the right thing for Indy Hall, but stuff like that's just been done, so.
Yeah. Awesome. Any ideas? Please reach out. No idea is stupid. We can, if it's something that can benefit the hall, we should definitely try and build it. So.
Do you have a plan for when it would start? Is there a date?
Not currently, but I think maybe sometime in December would probably make sense.
Okay, cool.
What do we need to know to get started on this? Maybe we've never done hardware stuff.
So if you're looking to get started, your best bet's going to be the Raspberry Pi. And Raspberry Pi has the Python GPIO library that is just as easy as it gets. So I would recommend that if you're looking to get started. Awesome. Well, thank you guys.